from Group Work Quiz, Chapter 3 in the section on projectile motion. This problem, a man in a circus is shot from a cannon elevated at 40 degrees above the horizontal with an initial velocity of 26 meters per second. In order for proper clearance, the cannon is located on a truck 4 meters above the ground. Part A, how long must the tent be? Or what is delta x, the displacement along the x-axis? At time equal to 0 comes a projectile. That would be when he exits the muzzle of the cannon as he's no longer being accelerated by the expanding gases in the cannon, and so there the only force is a gravitational force, and he becomes a projectile. X naught is 0, and y naught is 4 meters. So the problem is a projectile until he impacts the ground, and then the collision problem begins, the projectile problem ends. Delta y, or y final, which is 0 minus y naught, is minus 4 meters. And so the question is, what is delta x, which is x max or x hit minus x naught, which is 0. So to solve the problem, we write down the x equation, which is uniform motion. Delta x, or x max, is the initial velocity along the x-axis, or vx naught, which is the initial velocity 26 meters per second times the cosine of 40 degrees, which becomes 19.9 meters per second. So x max, vx naught times t hit is 19.9 meters per second times the time that the man hit the floor. So we need t hit. To find that, we must write down the y equation. So delta y minus 4 meters is vy naught t minus 1/2 the acceleration of gravity g times t hit squared. We put the numbers in, we get minus 4 meters is 16.7 meters per second times t minus 4.9 meters per second squared times t squared. We observe that this is a quadratic equation. We have established that to find the range of the cannonball person, we need to solve this equation. X hit is 19.9 meters per second times t hit. To find the time that the cannonball person hits the floor, we need to solve this quadratic equation. This requires the quadratic formula, where the solution to y is ax squared plus bx plus c equal to 0 is given by x is minus b plus or minus square root of b squared minus 4ac over 2a. We must set this equation to 0 to be able to apply the quadratic formula. So here we rearrange the formula, the quadratic equation, to do just that. So the a in ax squared plus bx plus c is the coefficient of t squared, or x squared, which is 4.9. B is minus 16.7, the coefficient of t, and the constant term, or c, is minus 4. We solve for b squared minus 4ac, or the thing that's underneath the radical, to see how many solutions we have. When we do that, we get a positive number, 357.3, which tells us there are 2 real solutions. So we need to know when the human cannonball hit the floor, or was it position y is equal to 0. The 2 real solutions include a positive solution, which is the one that we want because the problem started at t is equal to 0 right here when he was fired out of the cannon and became a projectile. The other solution, real solution, is negative, and so we need to discard that one. So we apply the quadratic formula to get the 2 real solutions. T1 is minus b, or 16.7, minus the square root of 357.3 all over 2a, or 9.8, And looking at the numerator, which is negative, we see that that is the negative solution, and we discard that. This gives us the other positive solution is 16.7 plus the square root of 357.3 divided by 9.8. That's 3.63 seconds. And so that is the time that we need to substitute in for t hit into the uniform motion x component of the projectile motion to solve. So now that we know the time that it took the human cannonball to hit the floor of the circus tent is 3.63 seconds, and so we plug that in, we substitute that into the uniform motion x component, and we get that x hit, or the range, or x max for the human cannonball is 72.3 meters. That completes part A. Part B, how high must the tent be? The tent needs to be the initial elevation when the human cannonball was fired of 4 meters plus the displacement above that position. So we recall that the y component of projectile motion is just free fall. We can do the need 3, fourth is what, fifth not known process. And so the 5 things are delta y, which is what we need, v sub y, and we know that v sub y at the top is 0. That's why it's not going up anymore. The time, we do not know that. Vy naught, well, that is v naught sine of theta, which is 16.7 meters per second. So that's 2 things that we know. We know Vy top is 0. We know Vy naught is 16.7 meters per second. And so we need one more, but that would be A sub y is minus the acceleration of gravity, minus 9.80 meters per second per second. So we have 3 things. The fourth is what? Delta y. And so that means that the equation that will work for us in one step is time not known equation. V sub y squared is Vy naught squared minus twice the acceleration of gravity times the displacement in the y direction. Vy top is 0. Vy naught is 16.7 meters per second. So we square that minus twice the acceleration of gravity times delta y. Algebraically we solve for delta y. And we get 14.2 meters. That is above the initial elevation of 4 meters. So 14.2 meters plus 4 meters, or 18.2 meters. The end.